Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So as you all are aware that presently we are going through our series of database management system DBMS, and the topic which we are pursuing currently is about SQL, and we have seen many of the commands and operations in SQL. So with that continuity, today's topic is about natural joins in SQL. So when we talk about natural join, this is basically comes under the umbrella of taking information or extracting information from two or more relations. So basically we can say we need to sometimes there are situations in which we need to have information from two or more relations. Those two or more relations needed to be joined together somehow, and then some information has to be extracted. So one of these ways we have seen in our earlier lecture, that was about the Cartesian product. So please recall, the Cartesian product was also kind of a way in which we were combining the two relation and extracting the information from that combined relation. So basically a Cartesian product was something which is along with a where clause predicate can be used to join information from multiple relations. So the information from multiple relations was joined on the basis of where clause predicates when we talk about the Cartesian product. So similarly, another way in which the information from two or more relations can be joined together is here the thing which is known as join. So here many joins are available, but we will be in this lecture we will be covering the natural join. So natural join, that is basically an operation that operates on, as I have told you, two relations and produce one relation as the result. So this can be two or more than two relations. We will be taking the examples of more than two relations as well. So now as I have told you that one of the way of joining two relations, combining two relation and extracting information is Cartesian product, and another one which we are presently studying, that is join. So what is the difference? So the first question that comes up in our mind is, what is the difference between then Cartesian product and our join? So let us see that. So unlike Cartesian product of two relations which concatenates tuples of the first relation with every tuple of the second relation. So in Cartesian product we have seen that one tuple of one relation, first relation is being taken and joined with all the tuples of the second relation. Here it is not going to happen. Natural join is going to consider only those pairs of tuples in which the same value of a particular attribute appears in the schemas of both relations. So for example, we have two relations and we have one common attribute, which is, let's say, ID. So natural join will consider only those pairs of tuples in which the value of ID in one relation will be similar to the value of ID in the another relations. Only those pair of tuples can be considered in natural join, while in Cartesian product each and every tuple of first relation will be combined with every tuple of the second one. So here if you can see, we have two relations, two tables, one is instructor and another one is teaches. So here if you can see, the first tuple of a relation instructor has been taken and it is combined with all the tuples of the second relation, which is teaches. Then the second tuple is being taken, then combined with all the tuples of the teaches relations, and so on and so forth. So this is the thing which was happening in the Cartesian product. But if we talk about natural join here, so natural join, if we take natural join between these two relations, so it is going to consider only those pairs of tuples where both the tuple from instructor as well as from the teachers have the same value on the common attribute. Now, what is the common attribute? If we can see the schema here, or if we can see the structure which is given here. So, we have ID, then name, then department name and salary in our instructor relation, and as far as teachers is concerned, it is having ID, course ID, section ID, then it is having semester and year. So, we can observe that the common attribute here is the ID. So, natural join will consider only those tuples which are having common value of the attribute ID. Now, how are we going to write the query? So, while writing the query, we need to take it as select name comma course ID from instructor natural join teachers. So, as you can see on the screen, it is select name course ID from instructor natural join teaches. So, the last line I am referring to, this is about joining combining the two relations using the natural join operation. While the earlier the idea was select name course ID from instructor comma teachers, where instructor ID is equals to teachers ID. So, this can also be done because this is achieving the same thing. Either we are going to write select name course ID from instructor teachers, where instructor ID is equals to teachers ID. This query can be written more concisely using the natural join operation in SQL, such as select name comma course ID from instructor natural join teachers. So, both the queries written in the first sentence and the written in the last sentence, both are going to give me the same result, but the second one, which is being written with the help of natural join, seems more concise, and because natural join is itself kind of we can say incorporating the condition of the common attribute, which is ID, and it is operating on the same or common values of the attribute ID. So, we need not to write where instructor ID is equals to teachers ID. So, that where clause we actually do not need here, while in the first we are going to say select name course ID from instructor comma teachers, the two relations, where instructor ID is equals to teachers ID. When we use natural join, we will be writing select name comma course ID from instructor natural join teachers. So, when we say natural join, instructor dot ID is equals to teachers dot ID is kind of we can say incorporated into that. So, here you can see the result of the natural join of that particular those two relations. One is the instructor and another one is your teachers. So, here we will be having ID, name, department name, salary, then we have course ID, section ID, semester and year, but tuples are the values in the tuples are having are there only for the values which are having ID as the common one. That means ID 10101 is available in the instructor, as well as this ID 10101 is also available in the teachers. So, whatever is the common ID available, that only we can say will only those tuples will be combined in case of a natural join, while this does not happen in case of a Cartesian product. So, yes, we have seen two different we can say mechanism of joining the two relations. One is the Cartesian product, another one we have just seen is natural join. Now, let us explore natural join into a more kind of detail. Here what is happening, it is not two things here are very important. One is in natural join, what all attributes what all tuples are being included in the resultant relation, also what is the order in which the attributes are listed. So, please remember that all those attributes which appears in the schemas of both relations will not be repeated, they will appear only once, and also the order in which the attributes are listed is very important. First, the attributes which are common to schemas of both the relations will be kind of, we can say, written. Then second, only those attributes unique to the schemas of the first relation will be written, and finally those attributes which are unique to the schemas of the second relation will be written. So, this is the way in which the attributes are being listed. When we talk about a from clause in context of a natural join, we can say that a from clause in an SQL query can have multiple relations combined using natural join. So, this is I was talking about, that it is not necessary that there should be only two what we can say, only two relations which are to be joined in a using a natural join operation. There can be multiple relations also. So, those multiple relations can be joined or can be combined using the from clause. So, this from clause says select A1, A2, whatever attributes you need from A1, A2 to AN from R1 natural join R2 natural join R3 till natural join Rm, where P is actually a predicate. So, we are going to write select the attribute names from R1 natural join R2 natural join R3 natural join till Rn, where the predicate, whichever predicate you want to include, that predicate can be included after the where clause. So, here we can say more generally, a from clause can be of the form E1, E2, En, where each EI can be a single relation or an expression involving natural joins, as we have seen in the query just above. So, from E1, E2, where this E can refer to a single relation, or it could be an expression involving natural joins. So, let us take one more example which is about the natural joins. Now, we are having list the names of the instructors along with the titles of the course that they teach. So, here we have to take some information from the instructor and some information from the teachers, because the titles of the course is available under the teachers relation, while the names of the instructor is available under the relation instructor. So, here we are going to write select for this particular query, we are going to write select name comma title from instructor natural join teaches comma course, where teaches dot course id is equals to course dot course id. So, here you can see the actual example of the template which I was just talking about. Select A1, A2, AN attributes from instructor natural join teaches comma course. That means here is actually we can say multiple relations which are given. So, first is the from instructor natural join teaches. So, the first relation which I am talking about here is a natural join of instructor and teachers, and the second relation from which the information is expected is course. So, one, that result of that join will be taken, another the course will be taken, and then where teachers dot course id is equals to course dot course id. That is the predicate on which this combination is going to take place. So, let us see the template once again, and then we will try to map this example with that particular template in order to have a better understanding. So, here we have seen select A1, A2, AN from R1 natural join R2 natural join R3 natural join Rn, where Pm. And now this after this from clause, when we are talking about the relations, these relations can be natural joins or these relations can be individual relations. So here in our example, in our actual example, we have seen select name comma title. These are actually your A1, A2, AN attributes, two attributes we have taken. From instructor natural join teaches, that is one relation which is the resultant relation of a natural join of instructor and teaches, and another relation is course. So from one relation comma another relation course, this information has to be extracted, name comma title. Now on the basis of which particular predicate? So the predicate here is where teachers dot course id is equals to course dot course id. So in this way, it goes. So the natural join of instructor and teachers is first computed, then a Cartesian product of this result with the course is computed, and from which the where clause, the predicate, is the information corresponding to that predicate, which mentions that only those tuples where the course identifier from the join result matches the course identifier from the course relation will be extracted. So first a join, and then the Cartesian product of that particular resultant relation which comes from the join and the course will be taken, and on those particular two we can say relations, a predicate has to be applied, and whatever information is coming up, that information is being we can say displayed, or that is the information we are looking for. Now in this we need to notice that the teachers dot course id in the where clause refers to the course id field of the natural join results, since this field in turn came from the teachers relations. So here we need to be very specific, or we need to be careful, I can say, that from where this particular attribute is coming. Now for example, if we want to write, if we think about having an alternate way of computing that particular result using an different SQL query, like select name comma title from instructor natural join teaches natural join course. Now what will happen? Is it going to give us the same result? So for example, in the previous query, I have taken the natural join of instructor and teaches, and that is going to form a Cartesian product with course. But here the query which now I am talking about is select name comma title from instructor natural join teaches natural join course. So instructor natural join with teaches and then natural joins with course. So is it going to produce the same result? Surprisingly, this query is not going to compute the same results, because now what is the reason? That reason we have to identify. The natural join of the instructor and teaches contains the attribute, what attributes? ID, name, department, salary, course ID, section ID, while the course relation is going to contain the attributes course ID, title, department name and credits. I repeat, the natural join of the instructor and teachers contains the attributes ID, name, department name and salary. These are the we can say attributes from the instructor, and then course ID and section ID are the attributes from the teachers, while the relation course is having attributes course ID, title, department name and credits. So as a result, the natural join of these two would require the department name attribute values from the two inputs to be the same. As I have told you, the common attribute, only the values of the tuples which are similar values of the tuples in the common attribute will be taken in the resultant relation of the natural join. So here the common attribute is, one is the department name. So here the natural join of the instructor and teachers along with the course would require that department name attribute values from these two inputs to be the same, in addition to requiring that course ID values will be the same, because that course ID is something which is given in the where predicate. So, this query would then omit all the instructor names, course title pairs where the instructor teaches a course in the department other than the instructor's own department. So, what is happening actually? If we can see, I am just repeating, this query would omit all the instructors, would omit all the instructor name, course title pairs where the instructor teaches a course in a department other than his or her own department. The previous query on the other hand correctly outputs such pairs. So, the bottom line here is we also need to see that when a Cartesian product has to be taken along with the natural join, or when the two natural joins are to be taken, and here we have seen an example of such we can say a mess up in which the result of both these two different operations are going to be very different. So, in order to provide the benefit of natural join while avoiding the danger of equating attributes erroneously, which we have already seen with the help of an example, the SQL provides a form of the natural join construct that allows us to specify exactly which columns should be equated. And what is the form? That is, select name comma title from instructor natural join teaches join course using course ID. So, here what we have done, we have specified the columns which should be we have specified exactly the columns which should be equated, and here is the way which is provided by the SQL in order to avoid the danger of that mess up which we have just seen. So, in this lecture what we have seen is we have methods of combining information from two or more than two relations. One of those methods which we have covered earlier was about Cartesian products, and the second method is about natural joins. But the list these are not the only two methods which are available, there are others also, and we will be covering those in our upcoming lectures as well. And we have also seen combining not only two but multiple relations, and what will be the kind of we can say reason for messing up the results if we are going with multiple relations, that we have also seen, and what is the remedy provided here, which is how we are going to specify exactly the column which is needed to be equated, that we have also seen. So, here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.